Now we are going to discuss about rotation of the earth. Rotation of the earth. Rotation of the earth. So rotation of the earth is first of all movement. Earth rotates on its axis from west to east. West to east. Okay. And the reason of the apparent motion of the sun from east to west, because sun also move towards the earth from east to west. So earth moves from west to east. Okay, apparent movement of sun is from east to west. So the movement of the earth is from west to east. Okay, earth rotates once in every 23 hours and 56 minutes and 4.0916 seconds. Apparent rotation from the north pole, the direction of the earth rotation is perceived as counterclockwise or anti-clockwise. Okay, direction. So from the north pole, if we are seeing from the north pole, this is the north pole, so there is the direction is anti-clockwise. Okay, and from the south pole the direction is clockwise. So from the south it is clockwise. Okay, so it is very important, like there is anti-clockwise and there is clockwise. Okay, AC, you can see there is A, there is C. Now velocity of the rotation. The rotation velocity at the pole is almost equal to 0. So there is the velocity is the almost 0. On the poles it is 0. And the greatest rotational velocity is on the equator. So 0 degree. This is the greatest velocity. We are talking about the velocity. Here is the greatest velocity on the 0 degree. Okay. And the line around the earth separating the light and dark half is known as the circle of illumination. So the half part is darker, half part is lighter. That is known as the circle of illumination. What is known? Circle of illumination. Okay. And the circulation of atmosphere along its layers, and Coriolis force is there also. Circulation, why it's circulating? Because there is a Coriolis force and circulation of atmosphere of the layer. And oceanic circulation is movement of water in ocean. So oceanic cycles takes 10,000 years to complete a complete rotation. So this is all about the rotation of the earth. Alright, now we are going to discuss about the latitudes and longitudes. So this is the earth, you can see. Here I made some diagrams of the earth. Okay, and this is how it's shown, like this, we can say. So this is, we can say, north pole, it is 90 degree. This is, we can say, south pole, it is 90 degree. Okay, and it is known as equator or 0 degree. Okay, so this is 180 degree, we can say 180 degree first of all, then 150 degree, then 120 degree, then 90 degree, then 60 degree, then 30 degree, then 0 degree, again 30, minus 60, minus 90, sorry, again minus 30, minus 60, it's 0, minus 90 or minus 120, minus 150 and 180. So this is all about the circle of latitude and longitude over the earth. So this is how it looks like. You can see like this. This is all about. So latitude are imaginary lines around the earth parallel to the equator. Latitude are the parallel to the equator. It is imaginary line parallel to the equator. Okay, also called the parallels, and characterize the latitude gradually decrease in the size from the equator towards the pole. So size is decreasing toward the equator towards the pole, and degree of latitude is greater at the pole. And if we are talking about the pole, it is the degrees higher, 1.7 kilometer than the equator. This is 110.7 kilometer. Okay, measurement. Latitude of place is angular distance measured either north or south from the equator. So distance between the latitude are constant. The length of the 60 degree latitude is half the length of the equator. So 60 degree latitude is here, it is the half of the equator. Okay, and the length of 75 degree latitude is 1/4 of equator, and the 75 latitude is the 1/4 and it is half. 60 is the half, it's not 50. Okay, and 75 is 1/4. Important latitude line, Arctic Circle. Arctic Circle is 66 and half. 66. Sorry, I'm showing you Arctic Circle. Okay, this is the Arctic Circle, 66 and half. This is 66 and half is Arctic Circle of North, and this 23 and half. 23 and half is North. Okay, it's Tropic of Cancer, and this is Tropic of Capricorn in southern point, and Arctic Circle is here minus 66 and half. Okay, it's an Arctic Circle, and it is Arctic and it is an Arctic Circle. It is Arctic, it is Antarctic Circle, and Antarctic Circle. Okay, and sample calculation, what is the distance? 12 degree north of equator. So solution is 12. If we are talking about 12 degree from north, 12 into 111.044 will be 1332.5 total kilometer. Longitudes are series of semicircles passing from north to south. So this is the longitudes. It's in semicircle. Okay, and also known as meridians. All meridians are equal in length. Meridians span 180 degree from east to west of prime meridian. It is prime meridian of 0 degree. From east to west is 183 degree. Okay, and all meridians across the equator are in right angle. So there is a right angle between the meridian. So degree of longitude is greater at the equator. It is also greater at the equator, 111.3, and decrease gradually towards the pole. And here the degree of longitude is 0 kilometer. Okay, so 0 degree meridian or the prime meridian is known that. So chosen in 1884, prime meridian divides the sphere into two hemispheres, passes through Royal Astronomical Observatory, Greenwich, London. Greenwich meridian has been adopted internationally as the standard meridian. Measurement, longitude of place in the angular distance between a point on any meridian and the prime meridian at Greenwich. Longitude of a place is measured either east or west from prime meridian. It shall be either east either west. Okay, and positive longitudes latitude and longitude counted west prime meridian called the positive longitude. It is called the positive, and negative is known the negative longitude. It is the negative longitude. So this all about we discussed today longitude and latitude. Now we are discussing about revolution of the earth. Revolution of the earth. Revolution of the earth. Revolution of the earth. Earth revolves around the sun only in every 365.2563 days. So plan of ecliptic. Earth revolves around the sun in ecliptic orbit called the plane of ecliptic. Plane of ecliptic. Earth equator make an angle of 23.5 degree plane in ecliptic. 23.5. And earth axis is inclined at angle of 66.5. Plane of ecliptic. Plane of ecliptic. Okay, so it is 23.5 in plane of ecliptic. That is known as the angle responsible change in the season. So change in the season is because of the plane of ecliptic is revolving around the plane of ecliptic. That's why there is a seasons. The speed of the earth revolving along its orbit is 107,000 km per hour, or 29.72 km per second. 29.72 km per second. Okay, now variation in the length of day and night. Poles experience 6 months of day and 6 months of nights. Poles experiences 6 month day and 6 month night. Okay, and tropic experience almost equal length of day and night, but in tropics there is equal day and night. Equal day and night. So in tropics there is the equal day and night. Okay, change of the season. For division of the year into spring, summer, autumn, winter, marked by particular weather pattern on the daylight hours. So there is the weather system also, like there can be summer, autumn, spring and winter. These are some 4 seasons will be there, you can see there. Okay, and now we are talking about the distance between earth and sun. The distance between earth and sun varies due to elliptical shape, because earth is in the elliptical shape, so that's why there is a difference between that earth's orbit. Okay, so perihelion, if we are talking about the perihelion, so perihelion is the between the like the earth is closest to the sun, earth is the closest to the sun, this is known as the perihelion. And aphelion, aphelion, if earth is farthest, earth is farthest towards the sun, so it is perihelion is the 47 million kilometer, and aphelion is 152 meter kilometer. Okay, change in distance between earth and sun does not cause any change in the length of the day or night, so there is no change in the day or night. Now we are discussing about the equinox. Equinox, what is equinox? So equinox, the day where the sun is vertically overhead at the equator. If sun is vertically overhead at the equator, it is known as the equinox. Vernal equinox is sun start to move towards the tropic of Cancer. If sun starts to move towards the tropic of Cancer, it is not the vernal equinox. And autumn equinox, if sun start to move towards the tropic of Capricorn, so it is the autumn equinox. Okay, so vernal equinox is on the 22 March, 21 to 22 March, and autumn equinox is towards the 22 to 23. It's 21 22, it's 22 to 23. And what is that? That is September, March and September. Okay, and change in distance between earth and sun does not cause any change in length of day and night. Again, insolation energy is equal in both the hemisphere, because of that there is a insolation is equal in the both of hemisphere in equinox. Now we are discussing about solstice is again we are discussing about summer solstice. Summer solstice, if sun is directly towards the 23 and half. Okay, 23 and half. So fall on June 21, it's on June 21 or 22. So this is sun is vertically overhead at the tropic of Cancer. It is vertically overhead at the tropic of Cancer. So this is known as the summer solstice. Longest day and shortest night at the northern hemisphere. Insolation energy is greater in the northern hemisphere. If the energy of the sun is falls vertically towards the northern southern hemisphere, sun is vertically overhead to the tropic of Capricorn. It is the tropic of Capricorn. So if there is the sun is the vertically overhead, then insolation energy is greatest in southern hemisphere. Leap year is what? If earth takes 365 and 1/4 day to complete one revolution, or 365 days and 6 hours, every fourth year the fraction of 6 hours from the previous 3 years is cumulated and added 29 February to form the leap year. So 6 hour difference always it's become, now it's to multiply 6 into 4, 24, it will be 1 day, so added in the 365 will be there, and that will be the leap year. So what discussed we today about the earth. Now we are going to discuss about time and international dateline. Time and international dateline. Okay, so international dateline, it is 180 degree, it is 180 degree longitude line where the earth changed their dates by 1 day were crossed, adopted the international meridian conference held Washington. It was in Washington, meridian conference. So a day is gained when crossed from west to east. West to east, if it is crossing, then 1 day will be gained by that. Lost when the from west to east to west, there will be loss always. Okay, east to west, always go in east, not in west. Okay, so time advance in eastern direction and decrease in western direction. Places Greenwich gain time, and places where Greenwich lost time. So units are, one revolution of earth is 360 degree. We know about the 360 degree equals to 24 hours. Okay, so 15 degree will be equals to 1 hour, and 1 degree equals to 4 minutes. So this is the difference between our time zones. Now we are discussing about the time zones. So there is France. France has the 12 time zone. Russia has the 11. UK has the 9 time zone. Russia 11. France 14. 12. Sorry. France and Russia. Now UK is 9 and Australia has the 8 time zone and Canada has the 6 time zone. Okay. So each zone differs 50 degree. Each zone differs 50 degree or 1 hour. There are 24 time zone in the world and continue with highest number of time zone. Okay, so now kinds like sidereal time. Sidereal time is the time measured by the diurnal motion of the stars. So diurnal motion of the stars, diurnal motion of the stars, motion of the stars are known as the sidereal time. Sidereal time. Okay, and the sidereal day is also divided into 24 hours, each hour into 60 minutes and each minute into 60 seconds. So sidereal day is also divided 24 hour, 60 minutes and 60 second. This is all about, it's divided. Next is apparent solar time. Apparent solar time. Apparent solar time is time as measured by the apparent position of sun in the sky. Sun dial is used to measure the apparent solar time. So dial of sun will be used to measure the apparent solar time. Apparent solar day is not of uniform length and hence it is synonymous with regular clock speed. So what is regular clock speed? That will be measured in that. Mean solar time. Time measured based on the diurnal motion of mean sun is called the mean solar time. Mean sun is an imaginary sun moving uniformly along the celestial equator to make a solar day of uniform length. So mean solar time was devised to rectify the drawback in apparent solar time. That's why mean solar time comes. So mean solar day is divided into 24 hour, each hour in the 60 minutes and each minutes in the 60 second. So two systems are there. Civil time, anti-meridian from midnight to noon, then post-meridian, then from noon to midnight. This is the civil time. Civil time is what? Anti-meridian from midnight to noon. Then noon to midnight is post-meridian time. Okay, anti is in night and post is in daytime. So astronomical time is start at 0 hours and end with 24 hours. That is known as astronomical time. Now the standard time. What is the standard time? Standard time, it is the uniform time for places in approximately the some longitude established in the country at region by law. So Indian standard time is 82.5 degree east. UTC plus 530 universal time coordinated. Okay, and IST is 82.5 degree east longitude in Shankargarh, Fort Mirzapur, Allahabad, UP. It is in Allahabad, UP. And Shankargarh, what the name? Shankargarh Fort Mirzapur. It is in Mirzapur and it is Shankargarh Fort. It is a fort of Shankargarh. So there is the Indian time 25.15 note to 82.58 note. So local mean time of place on eastern side of prime meridian is later than standard time. So western side of prime meridian earlier than standard time. So eastern side of time is later, but in western side of prime meridian is earlier than standard time. And eastern side of prime meridian is later than standard time. So these are some time zones I discussed.